Hey guys, today we're going to talk about conditions for special parallelograms. You'll need to make sure that you are writing fairly small because some of these problems have a decent amount of algebra and math to do. Okay, so make sure you're writing fairly small. Okay, so there's several different conditions for rectangles that you'll need to know. Let's read the first one, 6-5-1. It says if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Okay, so first thing you need to know is that the shape must be a parallelogram. Okay, so you have to know that it's a parallelogram. Two different sides are parallel, or opposite sides are parallel, and those sides are congruent. One of those things. Okay, and it is a rectangle if you have one of the angles being right. Okay, so that is your first property. Okay, second property, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, so if you know that it is a parallelogram and the diagonals are the same length, so this whole segment is congruent to this whole segment, then you have a rectangle. Okay, so those are the two things that you need to know about rectangles. Let's do an example. Okay, it says, a manufacturer builds a mold for a desktop so that AB is congruent to CD. Okay, so we have AB is congruent to CD, and BC is congruent to DA. Okay, since we have two sets of opposite sides that are congruent, you know that this is a parallelogram. And since we have a right angle, we know that this is a rectangle. Okay, so this is a rectangle. Sorry for my bad handwriting. This is a rectangle by 6-5-1. And if you remember, 6-5-1, it says up here, if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. And so that's where we get that. We know it's a parallelogram, and then it has one right angle, so it is a rectangle. Okay, so make sure you review these properties. If you're a little bit confused, go back, review those again. Alright, now we're going to move on to rhombuses. Now you covered rectangles in the last slide, and we're going to talk about rhombuses now. Okay, so three different theorems for you to know. The first one, it says if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Okay, so if you know it is a parallelogram, you must know that, and you have a set of consecutive sides that are congruent, then it is a rhombus. Remember, consecutive sides just means two sides in a row. It doesn't matter which two sides, you just have to have two sides in a row. In this case, we have these two sides. Okay, so since those are congruent, you have a rhombus. Second one. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, so if you have a parallelogram and the diagonals make a 90-degree angle, then you have a rhombus. So all of these angles would end up being 90 degrees. Okay, so if you have a parallelogram and the diagonals make a perpendicular line, then it is a rhombus. Okay, and lastly, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So what that's saying is if the diagonal, this guy, bisects these two angles, meaning that they are congruent to each other, then that thing is a rhombus. Okay, so let's take a look at a couple of examples. Let's see if what the conclusion is a valid statement. Okay, so let's look at number 2. It says determine if the conclusion is valid. If not, tell what additional information is needed. It says EF is congruent to FG, so let's go ahead and do that. EF is congruent to FG, and EG is perpendicular to FH. And we want to know that if this is a rhombus. Well, first thing you need to know is that it needs to be a parallelogram. Okay? Well, it doesn't really give you enough information to be a parallelogram. Okay? So it's not a parallelogram. Okay? So since it's not a parallelogram, it can't be a rhombus. Okay? So since it doesn't give you enough information to be a parallelogram, it's not a rhombus. But let's assume that it did give you enough information. Let's set that both of these were congruent. Okay? That would give you enough information that it could be a parallelogram. And since you have consecutive sides that are congruent, and you have a perpendicular line from the diagonals, it would be a rhombus. Okay, but in this particular case, it is invalid because it is not a parallelogram. Okay, so it's invalid because it's not a parallelogram. Okay, make sure that you are reviewing your 3 different parallelogram rules. Okay, let's try one other one. Okay, let's look at example number 4. It says determine if the conclusion is valid. If not, tell the additional information that is needed to make it valid. Okay, so first we know that ABC is a right angle. Okay, so that ABC is a right angle. And we want to know if that is enough information to tell us that ABCD is a rectangle. Okay, we know that ABCD is, it would be a rectangle if it is a parallelogram and if it has one right angle in it. And we know that it has one right angle in it, of course. Okay, but does it give us enough information to say that it's a parallelogram? Afraid not. Okay, it does not. Is not a parallelogram. Is not a parallelogram. So it's not a rectangle. Okay, you have to make sure that it's a parallelogram before you move on to any of the other properties. Okay. Alright, moving on to our last example for the day. Okay, and this one requires a little bit of work, so you're going to have to write small on it. Okay, so example 5, we're going to determine whether a given parallelogram is a rectangle, rhombus, or square. Okay, the first thing you need to know is that to be a square, you must be a rectangle and a rhombus. If you are both of those, then you are a square. Okay, so we're going to check for rectangle first, and rhombus second, and then if it's both of those, it will be a square. Okay? So the first thing you want to do is go ahead and plot your points. Okay, so we have -1, 4. -1, 4 is right here, and that is P. We have 2, 6. 1, 2, 1, 2, 3, 4, 5, 6. And that is Q. We have R, which is 4, 3. 1, 2, 3. Okay, that's R. And S gives us 1, 1. Okay, go ahead and connect your points. Okay, so the way that we're going to check to see if this is a rectangle is to go ahead and see if the diagonals are congruent. Remember, one of our properties is that diagonals have to be congruent. Okay, so we're wanting to see if PR is congruent to QS. And if that is true, then it is a rectangle. Okay, and the formula that we're going to use is our distance formula. I'm going to go ahead and write that down for you. Okay, so here is your distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and we need to find two pieces. We need to find PR and we need to find QS. Okay, so we're just going to plug in our ordered pair information and then we're going to go ahead and get started. Okay, so we're starting with PR, and remember we're just going to label these down the row. We got x1, y1, and x2, y2. Okay, so we're just going to plug these pieces of information into our distance formula and go ahead and churn it out. Okay, so let's go ahead and plug them in. We got distance equals the square root of our x2, which is 4. Our x1, excuse me, we got 4 minus 1 squared plus our y2, which is 3, minus our y1, which is 4 squared. Okay, so let's go ahead and reduce. We know 4 minus 1 is 5, and 5 squared gives us 25. Okay, so 4 minus 1 is 5, and then 5 squared, 5 times 5, gives us 25. Okay, then we have 3 minus 4, which is minus 1, and then minus 1 times minus 1 is 1. Okay, then you have 25 plus 1, and that ends up being the square root of 26. Okay, so you know that PR is a length of square root of 26. Okay, so you can go ahead and leave it like that. We're going to see if QS gives us the same length. Okay, so let's go ahead and plug in our points. Okay, so we have distance equals the square root, and this time we're doing Q and S. So we got x1, y1, x2, and y2. Okay, we can ignore P and R for now. Okay, so we have our x2 minus x1, and that's going to be 1 minus 2 squared plus our y2, which is 1, minus our y1, which is 6 squared. Okay, so let's go ahead and reduce. We have on the first set of parentheses 1 minus 2, which is minus 1. So we have minus 1 times minus 1, and that is 1. And then we have 1 minus 6, which is negative 5. And negative 5 times negative 5 gives you 25. Okay, and then if you add those up, that gives you square root of 26. Okay, so if you look, QS is square root of 26 and PR is square root of 26. That means that both of these diagonals are the same. So we know that this piece, or this shape, is a rectangle. Okay, so it is a rectangle. Now we're going to check to see if it is a rhombus. The way we see if a shape is a rhombus is to see if their diagonals are perpendicular or if they have opposite reciprocal slopes. Okay, so first I'm going to remind you what an opposite reciprocal slope is. Let's say you have a slope of 1/2. I'm just making this up. Okay, remember opposite reciprocal means to flip over and change the sign. So if you wanted to find the opposite reciprocal of 1/2, you would flip it over and change the sign. Okay, so that would be the opposite reciprocal of 1/2. Okay, so we want to find the opposite reciprocal slope and see if the shape is a rhombus. Okay, so we're going to find the slope between PR and QS. Okay, so let's do the rise over the run between P and R. So we got a rise of -1, and we got a run of 1, 2, 3, 4, 5. Okay, so PR gives us a slope of -1/5. Okay, so PR equals -1/5. Let's look at QS. Okay, so our rise is down 1, 2, 3, 4, 5, and left 1. Okay, so we've got -5 over -1. Okay, so QS is -5 over -1, or 5. Okay, so if you look at these two slopes between those two lines, that is an opposite reciprocal. You flip it over and change the sign, so it is a rhombus. Okay, so since you have a rectangle and a rhombus, you also have a square. And so once again, if you have a rectangle and you have a rhombus, that automatically means that you have a square. Okay? So if you just have one of those, let's just say you had a rectangle, it would only be a rectangle. If you only had a rhombus, then it's only a rhombus. Okay? It's only a square if you have both of those things. So make sure you remember your distance formula, and make sure you also know how to do rise over run. Okay? Review this example. It's a lot of information. Okay, go ahead and get started on your homework.